Okay guys, welcome back. So in the last video we talked about the basic concepts of limits. So in this video I'll be providing you with some examples or sample problems in which limits are used in the problems you face, right? So limits, I will explain it to you using various concepts or various sets or various applications. So as the first application in this video, I'll be talking about the application of limits in the general consequence of general equations. Now you have studied you understood in the last video about how the limit equations can be used, how when two functions are added to each other, how the limits add to each other, and when two functions are subtracted from each other, how the limits are subtracted, and the product and the quotient as well, and many other concepts. So in this video I'll be talking about some practical examples in which those theories come into play. So as the first example, I'll take an example, right? Take the limit to be the first example. Limit when x goes to 200, limit of 2x when x goes to 200, 2 times x. So this is my quiz, right? Limit of 2 times x when x goes to 200. So you know that you can substitute 200 in place of x, but only thing is that there's a constant here. So from the theories you learned in the last video, you know that if you were given a thing like this, or if you were given a sum like this, what you can do is that you can simply take this constant out of here. So that this is a very simple example. This is just the first example I'm using. So this is equal to, from the theorem, constant 2 times the limit when x goes to 200 x, right? So you know that this is equal to 2 times when x goes to 200, this x is equal to 100. So this is 2 times 200, which is 400, right? So that's just a simple example as to how limits come into play. So let's take another example. I'll say I'll take the limit of 3x plus 5. Limit of 3x plus 5 when x approaches minus 2. When x approaches minus 2, right? Now you know, if there's an addition, now this is one term, and this is another term, right? This is one term and this is another term. Now you know, now there's an addition here, right? Addition here, and you know by the theory that you learned in the last video that when there's an addition inside a limit, you can add these two separately, or you can take the addition of the limits. So if you have limit when x goes to 0 a plus b, you can say that is equal to limit when x goes to 0 a plus limit when x goes to 0 b. So what I'll do here is, first of all, I'll break these two into two limits with a plus sign. Alright. So this is also equal to limit when x goes to minus 2, 3x plus the limit of 5 when x goes to minus 2. Right? The limit of 5 when x goes to minus 2. So as in the last example, you know that if there's a constant like this, you can take this constant out of this limit, right? So as the next step, what I'll do is that when limit of 3x when x goes to minus 2 is equal to 3 times the limit of x when x goes to minus 2. So this is 3 times the limit of x when x goes to minus 2. Whether x goes to minus 2 or not, when x goes to minus 2 or minus infinity or minus any value, when there's no function of x here, only there's a constant here. The value of limit when x goes to minus 2 of 5 is 5 because there is no x here, right, to substitute. So whether x goes to minus 2, x goes to minus 10 or minus infinity, the limit of 5 when x goes to minus 2 is equal to this constant 5. So this will be plus 5, right, plus 5. So when x goes to minus 2, the limit of x is equal to minus 2. So this will be equal to 3 times minus 2 plus 5, right? So 3 times minus 2 is minus 6. Minus 6 plus 5 is minus 1. Right? So the limit of 3x plus 5 when x goes to minus 2 is equal to minus 1. When 3x plus 5 approaches, when x approaches minus 2, 3x plus 5 approaches minus 1. Alright. So let's take another example in which we have a power. Right? We have a power to solve. Take an example. Like this. Limit of 5x squared when x goes to 4. The limit of 5x squared when x goes to 4. The limit of 5x squared when x goes to 4. So you know whether this is x or x squared or x cubed, when there is a constant with some power of x, whether it's 1 or 2 or 3, the power of x, when there's a constant here, you can take the constant out, right? So that's the first step of solving this limit. So that will be 5 times the limit when x goes to 4, x squared. Now you know that x squared is equal to x times x, so I can write that here. So this is also equal to 5 times the limit of x when x goes to 4, x squared. So what actually happens is that if you are a well proficient user of limits, you can directly substitute 4 in place of x and find this. So there may be users, there may be viewers on this video who are not well proficient with this. So what I'll do, I'll break this into 2 parts. So you can write x squared as x times x. So x times x is a multiplication. One multiplication times this one. So what actually happens is that you can write this one as 5 times limit of x when x goes to 4 times the limit of x again when x goes to 4. Right? 5 times the limit of x when x goes to 4 times the limit of x when x goes to 4. So what I actually did was that I broke this x squared into 2 x's, x times x. So when there's x times x inside this limit, what I can do is that I can take the limits of these 2 individual components and then I can take the multiplication. And since there's a constant here, I have to multiply by that constant as well. So this will be 5 times when x goes to 4, the limit of x, right? The value of x when x goes to 4 is equal to 4. And this is also 4. So 5 times 4 is 20, 20 times 4 is 80. Right? So that's a simple example in which a power of x or any other constant comes into play and we have to find the limit. So let's take another example in which we have a quotient. Now in this example I actually discussed 2 topics. One is the using a power and the other is when you are using the multiplication of 2 terms. Right? So I actually reminded you of 2 concepts that we are just using under limits. So in the last sum I will be discussing in this video, I will take a limit of a quotient. So let's take a simple example. I'll take the limit to be the limit when x goes to 2, limit n x goes to 2, 2x plus 5 divided by 5x plus 4. 2x plus 5 divided by 5x plus 4. Right? So 2x plus 5 divided by 5x plus 4. So you know that when you have a quotient and you have to find the limit, what you have to do is you have to put the general equation. Right? So this is actually equal to limits when x goes to 2, 2x plus 5 divided by 5x plus 4 is equal to, you have to take the limits of the numerator divided by the limit of the denominator. So that will be limit when x goes to 2, 2x plus 5 divided by the limit when x goes to 2, 5x plus 4, right, like this, limit of 2x plus 5 when x goes to 2 and limit of 5x plus 4 when x goes to 2. So you know that this from the second example. So from the second example I taught you in this video, now you know that what I can do, you can do is that you can directly substitute the value of 2 in place of x here and x here as well, right? I will not write individual steps because I just explained to you little while ago how you can solve such an equation, right? Algebraic equation in which the x's power is 1, right? A linear equation. So what I'll actually do is I'll directly substitute the value of 2 in place of x here and here. So 2 times 2 is 4, 4 plus 5 is 9 here. So it will be 4 plus 5 divided by 2 times 5 is 10. So this will be 10 plus 4. So 4 plus 5 is 9 and 10 plus 4 is 14. So this will be equal to 9 by 14. So that's just another simple example in which a quotient, we have to find a limit of a quotient. So in this video I talked about the general concepts, the general equations that we have been using so far under limits, and also how to actually apply the concepts of limits when you are given some practical examples. So in the next video I'll be talking about some complex problems or complex samples that you will meet with under the topic of limits. So thanks for watching this video and see you then.